Math Singer, yum!
Hello and welcome to a Math Singer tutorial on limits. Today we're going to be investigating the limit as x approaches 0 of the function square root of 2 plus x minus square root of 2, all divided by x. There are several ways in which we could investigate the value of this limit, and we're going to look at this limit to begin with graphically. And we can look at this graphically by first examining the graph of the function square root of 2 plus x minus the square root of 2, all divided by x. Well, whenever we investigate the graph of this limit near where x is equal to 0, we see that the y value that we're seeking is going to be around, let's see, here's 0.1, here's y equals 0.2, 0.3, and 0.4. Looks like the y value whenever x is near 0 is somewhere around 0.35. Now, at 0, we can see that the value of the function is actually undefined. Many students mistakenly believe that whenever the value of the function is undefined at the point at which the limit is being investigated, that they believe the value of the limit is undefined. This is not always the case. As, of course, what we see here is that whenever x is 0, the numerator is equal to the square root of 2 plus 0, so the square root of 2 minus the square root of 2, which is 0, numerator is 0, and the denominator whenever x is 0 is also 0. So, in fact, 0 over 0 is undefined. Again, this does not mean that the value of the limit is undefined. Limits do not concern themselves with what is happening at the value, but near the value at which x is being investigated. And if we look at the value of the function whenever x is near 0, let's say at 1/10, what we see is that the value of the function is near 0.35. Here we have 0.349. If we looked at the other side of 0, so a negative number that is near 0, if x is at negative 1/10, we see that the value of the function is at 0.358 and a bit. So it looks like the value of the limit, again, the limit is the y value at which the functional values are approaching as x gets close to 0. It looks like those y values are near 0.35. If we get a little bit closer to 0, let's say at negative 1/100th, we have 0.3539. At negative 1,000th, we have 0.35359. For the positive values of x, well, at positive 1/1000th, we have 0.35350. So, in fact, it does look like the value of the limit is near 0.3535. Again, what this says is whenever x is near 0, the value of y is near 0.3535. Now, we've looked at this graphically. We have looked at this limit algebraically by investigating what the value of the function is at values of x near 0. None of these methods are likely to impress your teacher a great deal. What your instructor is probably going to want is the exact value of this limit whenever x is approaching 0. And we can evaluate the limit exactly by investigating this limit analytically. That's what we're going to do next. Let's begin by writing the limit as x approaches 0 of the square root of 2 plus x minus the square root of 2 all divided by x, and recognize that what we have is, in the numerator, an instance of x being trapped under the radical sign. Well, we would like to find a way of re-expressing our function such that both the numerator and the denominator have a common factor. And it looks like, by looking at the denominator, that common factor is probably going to be x. So we need to free up the x in the numerator in some way. Well, a common way of doing that in a situation like this is to multiply by the conjugate of the expression that has the x under the radical sign. So what we're going to do is we will copy down the limit as we've written it, and then we're going to multiply this entire expression by the number 1, which of course it does not change the value of the function. But the form of 1 that we're going to use is the conjugate of our numerator divided by itself. So the square root of 2 plus x plus the square root of 2 divided by the square root of 2 plus x plus the square root of 2. Well, whenever we do this, in the numerator, we now have an expression of the form a minus b times a plus b, and so we're going to be able to rewrite the numerator as a squared minus b squared. Well, the a is the square root of 2 plus x. Well, square root of 2 plus x times itself is just 2 plus x, and the square root of 2 times the square root of 2 is just 2. Whenever we multiply the bottom two terms, we have x times the quantity square root of 2 plus x plus the square root of 2, which looks a bit of a mess, but that's not a problem because we have met our first goal of finding a common factor in both the numerator and the denominator. That common factor, of course, is x. And so this expression includes the form x over x, which is just 1. So we can now rewrite this limit as x approaches 0 of 1 divided by the square root of 2 plus x plus the square root of 2. And we're now in a situation where whenever we evaluate our expression at 0, we no longer have an undefined expression. The numerator is 1. The denominator is the square root of 2 plus the square root of 2. And so we have a final answer of 1 divided by 2 square roots of 2, which you will find is very near 0.3535. This is the exact value of our limit. If you found this video to be useful, we hope that you will consider liking it and subscribing to this channel. For now, thank you for viewing, and I will see you in the next video.